Welcome to Teppy.
You know the feeling. We've all been there. You type in a website, you hit enter, and you get nothing. Connection error. Now, it seems like a really simple problem, right? But underneath that one error message is a huge hidden world of complexity. So when something like this breaks, where do you even begin to look?
Well, believe it or not, things used to be way worse. In the early days of networking, it was pretty much chaos. See, if you bought a computer from one company, there was no way it could talk to a computer from another company. They all used their own private, incompatible systems. They basically spoke different languages. An idea like the global internet, it would have been completely impossible.
To fix this digital mess, the International Organization for Standardization came up with something called the Open Systems Interconnection Model, or what everyone just calls the OSI model. Now, it's super important to understand that the OSI model isn't a piece of hardware or some software you can download. It's a universal map, a shared blueprint that breaks down the entire messy process of network communication into 7 clean, understandable layers.
And you know, the real genius of this layered map is that it gives us a divide and conquer strategy for figuring out what went wrong. Instead of trying to fix that broken connection all at once, we can just use this map to check for problems systematically, one layer at a time. So for this explainer, that's exactly what we're going to do. We'll start at the very bottom and work our way up to solve our little connection issue.
All right, let's start at the very beginning. Layer 1, the physical layer. This is the absolute foundation. It's all the actual hardware that plugs in and connects everything together.
Think of this layer as the actual nervous system of the internet. We're talking about the tangible stuff, the copper Ethernet tables running through your walls, the glowing fiber optic lines under the ocean, even the Wi-Fi signals flying through the air in this room right now. This layer has only one job: to turn digital bits into signals, electrical, light, or radio waves, and just send out those raw ones and zeros.
So when you're troubleshooting, this is always step 1. And it sounds so basic, I know, but you would be shocked how often this is the fix. Are the cables plugged in all the way? Do you see those little green lights blinking on your router? Is your Wi-Fi even turned on? Because hey, if there's no physical connection, nothing else matters.
Okay, so our cables are plugged in, the lights are blinking, we have a physical signal. Now we need a reliable way to actually send data across that connection, but just between 2 devices that are on the same local network. And that is the job of Layer 2, the data link layer.
What this layer does is take all those raw ones and zeros from layer 1 and groups them into nice organized packages called frames. And to make sure these frames get to the right computer locally, it uses a unique hardware serial number that's burned into every single network card on the planet. That's called a MAC address. Think of it like a local mail carrier who only works on your street and knows every single house number by heart.
So at this stage of troubleshooting, we're asking, can my computer even see my router? A really common test for this is to ping your local router's address. If you get a reply, it means Layer 2 is working. Your computer and your router are having a nice little local chat.
All right, so our local mail carrier is doing their job perfectly. But we don't just want to send mail to our next-door neighbor, right? We want to send it across the world. So, what happens when our data needs to leave our local street and head out onto the giant global internet?
Well, that brings us to Layer 3, the network layer. This is the global postal service. It takes that local frame from Layer 2, wraps it inside something called a packet, and slaps on a new kind of address, the one you've probably heard of, the IP address. Its main job is routing, figuring out the best, most efficient path for that packet to travel across thousands of different networks to reach its final destination.
Now, if our local pings are working, but we still can't get to, say, google.com, the problem is probably here, at Layer 3. We'd start asking questions like, does my computer have a default gateway? That's just an address that tells it where to send data that's supposed to go outside. Can we reach an IP address outside our home? It's all about making sure our data has the right roadmap to navigate the internet.
So our packet has its directions. It's on the right path to the server. But, a big file or a website is made of thousands of these tiny packets. How do we make sure they all arrive, that they arrive without errors, and that they get put back together in the right order?
This is where Layer 4, the transport layer, comes in. You can think of this as the quality control department for our global shipping company. It takes big chunks of data, breaks them into smaller pieces called segments, and then makes sure they all arrive safe and sound and get reassembled correctly. It also uses something called port numbers to make sure that website data goes to your web browser and not, say, to your video game.
And this layer offers 2 very different kinds of delivery service. First, there's TCP. TCP is like sending a package that requires a signature. It's a little slower because it checks and double-checks and confirms every single piece was delivered perfectly. This is what you need for websites and emails. Then you have UDP. UDP is like throwing a postcard in the mailbox. It's super fast, with very little fuss, because it just sends the data and hopes for the best. It's perfect for things like video streaming or online gaming, where a tiny glitch here and there doesn't matter, but speed is everything.
And that brings us to the very top of our model. The last three layers, session, presentation, and application, are often just grouped together. That's because they're all about the software side of things, and they work really closely together to serve you, the end user.
So layer 5, the session layer, is like the conversation manager. It opens a communication channel, keeps it open for as long as it's needed, and then closes it down neatly. Then you have layer 6, the presentation layer. This is the universal translator. It handles stuff like encryption and data compression, making sure both computers can understand each other, no matter how their internal systems work. And finally, layer 7, the application layer. This is the one you actually interact with. It's your web browser using a protocol like HTTP to ask a server for a web page. It's where all this data finally becomes a website or an email or a video that you can see.
Now, this 7-layer OSI model we've just walked through is the perfect theoretical map. It's the best way to learn and to troubleshoot. But in the real world, the internet we use every day actually runs on a slightly more streamlined model that was developed alongside it.
It's called the TCP/IP model. And as you can see, it's really a more practical, condensed version. It takes those top 3 OSI layers, application, presentation, and session, and just squishes them into one application layer, since one piece of software usually handles all those jobs anyway. Then it bundles the bottom 2, data link and physical, into one network access layer. So yeah, the TCP/IP model is what's actually running things, but it's built entirely on the beautiful, logical concepts that the OSI model defined for us.
So you might be thinking, hold on, if we actually use the TCP/IP model, why did we just learn all 7 layers of the OSI model? And that's a fantastic question. The reason is that the OSI model is still absolutely crucial. First, it gives us a universal language so that IT pros all over the world can talk about the same things. Second, it gives us that powerful step-by-step troubleshooting guide we just used. And third, it's the absolute cornerstone of all networking education. If you want to understand how networks really work, you start here.
Understanding this model, it really changes your whole perspective. You're no longer just a passive user of some magic box that connects to the internet. You now have the map. You understand the fundamental architecture of our connected digital world, and you can see the invisible processes happening all around you.
So, what's the most interesting thing you learned about the OSI model? Let us know your thoughts in the comments below. And of course, if you found this explanation helpful, don't forget to like and subscribe for more from TechA. Thanks for watching.